Okay, we are going to start our trigonometric functions unit. And a bit of a reminder, and because y'all should have seen some of this from geometry and algebra 2, but we will review just to make sure. So if we're talking about a sine of an angle, we need to remember that that implies that we have an opposite over hypotenuse. Cosine of an angle would be adjacent over hypotenuse, and tangent is opposite over adjacent. And that's useful for us to remember. And when we talk about cosecant, then it's going to be the reciprocal of sine. So we're going to talk about hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. And then cotangent would be adjacent over opposite. It's very important for you to remember those trig ratios, and do keep in mind that your sides opposite and adjacent, they do change depending on the point of view that you're looking for. So always make sure you locate your angle first. Now, the first thing we need to talk about as far as trigonometric identities would be what our reciprocal functions. The reciprocal function cosecant is really the same thing as 1 over sine theta. Secant is 1 over cosine theta, and cotangent would be 1 over tangent. You really need to make yourselves a note card or something to help you remember those values. Alright, so using those values, we are going to answer these questions. And before you start picking off any sides or anything like that, I encourage you to label your triangle. In other words, you're going to find that angle theta that's in question first. Do remember that the right angle does point out the hypotenuse. You can always make an arrow out of it and find that hypotenuse. And then from this, the side across or opposite, and then the side here that is touching that angle, that is your adjacent. So now we have all of our sides labeled. It's just a matter of filling in. Now sine, again, that was opposite. So that's going to be 12 over hypotenuse, which is 13. Cosine would be 5 over 13. And tangent would be 12 over 5. For cosecant, well, we can look back at our original function and just do the reciprocal. So if sine is 12 over 13, cosecant is 13 over 12. Secant is 13 over 5. And cotangent is 5 over 12. Okay, moving on to number 8. Again, we'll do the same thing before you start any process. Do label your sides. And again, here's my right angle. And so it is pointing to our hypotenuse. So I know this side here is our hypotenuse. Here is the angle that we're given. So this side way over here, that's going to be the opposite side. And this side here that's touching that angle, that is your adjacent side. And now that we have those, then we can go ahead and label our sides or our values. So sine, again, was opposite over hypotenuse, 4 root 5. And we do need to rationalize here. We can cancel those 4's. And we're going to have 1 over root 5, multiply top and bottom by root 5 over root 5. So we have root 5 over 5. And then cosine, we're going to have adjacent over hypotenuse for 4 root 5. And again, we can cancel the 4 into 8, and then we need to do our rationalizing, and so that's going to give us 2 root 5 over 5. And then tangent is going to be opposite over adjacent, and that does reduce to 1/2. So very quickly we know cotangent is just going to be 2, so it's all right to get those. Now I would go all the way back before we rationalize to do cosecant. Before we rationalized, that would have been this value right inside here. So if I looked at the reciprocal of 1 over root 5, that's just going to give us root 5. And the same is true with the other. If we look at what we had before we rationalized, that would have been a 2 over root 5. So to flip that over, we're going to have root 5 over 2. Now, for our next problem, we are not given all of the values of our right triangle. Now, notice again, if we start labeling, we do have our hypotenuse. And we have this side here, which is touching our angle, so this is adjacent. But we do not have our opposite side. So we're going to have to find that, and we will use the Pythagorean Theorem. Quick review of that. We're going to have a squared plus b squared equals c squared. And we're going to plug into that formula. So when we start plugging in, again, we have our hypotenuse, which is our c. So our other, it doesn't matter which side we let 20 be. And then we have b squared equals 29 squared. And after we do all of our algebra, we'll subtract over. We're going to get b to be 21. So now we know that missing side. Now we can go through and label all of the other sides. So sine is going to be 21 over 29. So cosecant we know is 29 over 21. Cosine is going to be 20 over 29. So secant is 29 over 20. And then for tangent, we know that is opposite over adjacent. So that's going to be 21 over 20. And so cotangent is 20 over 21. Okay, and moving along, we'll do the same thing to our other problem. Now, you do need to be careful when squaring this. You are squaring the whole side. Now, this time, pointing out our hypotenuse, that's the part that's missing. So we have one side, and we need to make sure we put 6 square root of 3 all in parentheses, especially if we're typing this in our calculators. And that's going to equal our missing side squared. And so when we square this, you do need to square the 6. And then if you square the square root of 3, that's just going to generate a 3 plus 36 equals c squared. And so solving this either with your calculator or whichever, it looks like we're going to end up with 144. So the square root of 144 is 12. So we see this other side is 12. Now we're ready to go through and label do our trig functions. Sine again of the angle here. So going across, that's your opposite side. This side touching is your adjacent. And of course, this is your hypotenuse. So we're going to have 6 square root of 3 over 12. And the 6 and the 12 do cancel. So that's the square root of 3 over 2. And so if for our cosecant, we're going to do the reciprocal. So that's 2 over the square root of 3. And once we rationalize that, that's going to give us 2 root 3 all over 3. Cosine is going to give us 6 over 12. And that's going to be 1/2. And so the reciprocal is 2. And then tangent is going to be our opposite over our adjacent. So that's going to be 6 root 3 over 6. Yep. And so that's going to give us root 3. So the reciprocal is going to be 1 over root 3. And once we rationalize that, we're going to have root 3 over 3. For our next problem, we are just given a side and just about nothing else. So we have to remember that what we're looking at is tangent, and tangent is really equal to the opposite side over the adjacent side. So we're going to label our sides. Now, as usual, we know that's our right angle. And as far as theta, you can put it anywhere you want to. So if I want to put theta down here, then I know this side over here is going to be opposite, and this side down here is going to be adjacent. And then those would swap depending on where you put theta. Now let's go ahead and find our hypotenuse. So we'll do our Pythagorean Theorem. 7 squared plus 24 squared equals our missing side squared, so we'll call that c squared. And so after we do all of our calculator work, we get that missing side to be 25. And now we're ready to go through and label our trig functions. Again, sine is going to be 7 over 25. So cosecant is 25 over 7. Cosine is 24 over 25. So secant is 25 over 24. And tangent is going to be 7 over 24. Cotangent 24 over 7. Okay, and so here notice that we are told cosecant, which is the reciprocal of sine. So the side lengths that we know now would be hypotenuse and opposite. And so we're going to go ahead and draw our triangle. And again, here it doesn't have to be just perfect. And as far as what you label where, that's up to you. I would go ahead and label this my right angle. And either place you can choose for theta. I'm going to put theta down there. So my hypotenuse I know is 37. And my opposite side is 12. And so now to find that missing side, we would have 12 squared plus the missing side squared equals 37 squared. And so working all that out, we see that our missing side is going to be 35. So I'm going to have my 35 here. Now, let's go ahead and figure out our trig functions. So sine of theta is going to be 12 over 37. And so cosecant, we know that was given to us, 37 over 12. And then we're going to have 35 over 37, 37 over 35. And tangent is going to be 12 over 35. And then cotangent 35 over 12. Okay, continuing on, again we're given cosine, so that tells me that we know the adjacent side and we know the hypotenuse. And so we can go ahead and draw our triangle and label those sides however. And so I'm going to put my right angle as usual there. But I'm going to change it up a bit. I'm going to put theta up here for a change. And so I know my adjacent side is 5. I know my hypotenuse is 9. And so to find that missing side, we're going to have 5 squared plus that missing side squared equals 9 squared. And so working out this one, notice that we're going to have 25 plus b squared equals 81, and b squared is going to be equal to, let's see, 56, I believe. And when you take the square root, 56 will break down. So we're going to have b is equal to, and let's see, we're going to have 4 times 14, so 2 root 14. So I know my missing side is 2 root 14. And now we're ready to fill in those trig values. So again, sine is going to be opposite, so 2 square root of 14 over hypotenuse. And so our reciprocal, we're going to have 9 over 2 root 14. And so when we rationalize here, it looks absolutely terrible that we are going to multiply top and bottom by root 14 and root 14. And so that's going to give us 9 root 14 over 2 times 14. So that's going to give us 28. All right, for cosine, again, we're going to have adjacent over hypotenuse, and so that's going to give us secant 9/5. And then for tangent, we're going to have opposite, so 2√14 over adjacent. And then when we do our reciprocal, we have 5/2√14, and rationalizing, that's going to give us 5√14 over 28. Right? And so looking at our next problem, a lot of times people lose their cool on this one, but do keep in mind that is really 4/1. You can turn any whole number to a fraction. And so secant is the reciprocal of cosine. So I know 4 is the hypotenuse. And 1, that 1 there, that is going to be our adjacent side. So sketching a triangle, that's going to allow us to label those sides for sure. So here we're going to have our right angle. I'm going to put theta down here. You're welcome to put it at the other angle. And so my hypotenuse is 4. My adjacent side is 1. And so to find that missing side, we have a squared plus 1 squared equals 4 squared. And so going through the process here, a is going to be the square root of 15. And so now we can fill in our trig values. So sine, again, that is going to be opposite over hypotenuse. And so the reciprocal, we're going to have 4 over the square root of 15, which will rationalize to be 4√15 over 15. Cosine is going to be 1/4, and secant is going to be 4. Tangent is going to be opposite over adjacent, and then cotangent is going to be the reciprocal of that. And so when we rationalize, we have √15 over 15. Okay, for this next example, we need to label these sides, and these stay in a special relationship, and that's why these are called special angles. Here, across from the 90-degree, that's going to be the longest side, and we're going to call that side 2. And across from the 30 is the smallest, and we're going to label that 1. And across from 60, we're going to call that the square root of 3. And you can prove that with the Pythagorean Theorem, but you don't have to. And so to develop a formula for this, we really just put an x out here out front. And so when you do that, you have a formula that will generate any of those side values. Also, in addition to that, you can fill in this chart with all of our values. And so here for 30 degrees, and we can even do 60 from this one, we are going to have sine of 30 is 1/2. Cosine of 30, again, that's going to be adjacent over hypotenuse. So cosine of 30 is going to be √3 over 2. And tangent is going to be here opposite over adjacent. So we're going to have 1 over the square root of 3, which will rationalize to be √3 over 3. And then we go through our reciprocals. So cosecant is going to be 2. Secant is going to be 2√3 over 3. And cotangent is going to be √3. All right, and let's go ahead and talk about the 45s while they're here. Now, the 45, this is an isosceles right triangle. And so these side lengths, we could call those 1 and 1. So that would make this other side the square root of 2. And to make a formula out of it, we're just going to multiply all these sides by an x. And so there's our formula to find any side. Now, if we want to know those specific angles, again, we're going to do sine of 45, which is the square root of 2 over 2 after you rationalize. Cosine is the same exact thing, and tangent would then be 1. And so whenever we do our reciprocals, then that's going to be √2 root 2, and 1. Now we're back to our 60 degrees, and sine of 60 opposite over hypotenuse, so root 3 over 2. Cosine adjacent over hypotenuse, 1/2. And then opposite over adjacent, root 3 over 1, or just root 3. And so cosecant, again, we're going to fill that in. That's going to be our reciprocal. After we rationalize, we get 2 root 3 over 3. We have 2, and then root 3 over 3. These are very important values that you need to learn, and you're more than welcome to put those on a note card if need be, but we will eventually be filling in the unit circle with these.